I'm going to show you the golden rectangle. I'm going to start here with a square that's 2 on each side, so a square of side 2. I want to go to the midpoint of this side and kind of bisect it here, so that length is 1 and that length is 1. Then I'm going to draw this diagonal in. Let me get a ruler here. Draw this diagonal in that goes from this midpoint up to that vertex of that square. And then what I want to do is drop that down, that length down, and extend this side right here to meet that. Now when I do that, then the rectangle that I get is called the golden rectangle. Let me see if I can just quickly draw it in right here. There's my golden rectangle. And so what I want to do is find the ratio of the length to width in the golden rectangle, because in mathematics that's a very special number. So if I look in this little right triangle right here, I see that this side is 1, this side is 2 because that was my original square, and so by the Pythagorean theorem I know that this side is going to be square root of 1 squared plus 2 squared, square root of 1 plus 4, or square root of 5. So this length is square root 5. That means that this length right here is square root 5. And this little length is 1, so if I want the ratio of length to width in the golden rectangle, the length is 1 plus square root 5. And the width is this width right here, which is just 2. So this number right here, 1 plus square root 5 over 2, it's an irrational number, but it's also called the golden ratio. Very special number in mathematics. If you work this out on a calculator, it's approximately equal to 1.618. Of course, I can't write it as a decimal because it's an irrational number. So the golden rectangle, when I find the ratio of the length to width in that, I end up with what's called the golden ratio. Now I want to show you a little postage stamp from Japan that kind of this little derivations on it, as you can see, sort of vertical rather than horizontal the way we did it, but very important derivation in mathematics, so important that they actually put it on a postage stamp.